Among the lesser-known roles of vitamin B9 is its subtle, yet intriguing potential to protect hearing, particularly as we age. While folate is widely recognized for its contributions to DNA synthesis, red blood cell formation, and fetal development, emerging research suggests it may also offer a degree of auditory preservation, especially against the backdrop of age-related hearing loss, presbycusis, a condition that affects nearly 1 in 3 people over the age of 65. Although the connection may seem unlikely at first glance, the mechanisms that support this protective effect, vascular health, nerve integrity, and homocysteine regulation, align closely with folate's known biochemical functions. One of the primary hypotheses linking folate to hearing preservation involves its ability to regulate homocysteine, an amino acid that in elevated levels is associated with vascular damage and neurotoxicity. The cochlea, the spiral-shaped structure in the inner ear responsible for translating sound waves into electrical signals, is particularly sensitive to vascular changes and oxidative stress. It relies on a dense capillary network to maintain the delicate ionic and metabolic environment necessary for hearing. Elevated homocysteine can impair this microvascular system, contributing to reduced oxygen delivery, inflammation, and even direct damage to auditory neurons. Folate, along with vitamins B6 and B12, plays a central role in converting homocysteine into methionine, thereby lowering circulating levels and potentially protecting the tiny blood vessels and neurons within the cochlea. Beyond homocysteine metabolism, folate's role in supporting the nervous system may have direct relevance for auditory function. The auditory nerve, which transmits signals from the inner ear to the brain, is highly dependent on myelination and efficient neurotransmission, both of which are influenced by methylation, a process driven by folate. Adequate folate levels support the synthesis of acetylmethionine, SAMe, a compound critical for the methylation of myelin proteins and neurotransmitter metabolism. This implies that chronic folate insufficiency could contribute not only to vascular issues, but also to progressive nerve degradation in the auditory pathway, leading to slower signal conduction and perceptual hearing decline. What makes this connection even more compelling is the consistency of findings across observational and interventional studies. In a well-cited prospective study from the Netherlands, older adults with lower blood folate levels experienced more rapid declines in hearing acuity over a 3-year period than those with higher folate levels. Additionally, folic acid supplementation was shown to slow the rate of hearing loss in participants who began with marginal folate status. While not all studies agree, some show only modest effects or limited impact in populations with already adequate folate. These data open the door to deeper exploration, especially in the context of subclinical deficiencies that may go unnoticed but exert long-term effects on sensory systems. Another intriguing angle is folate's influence on oxidative stress, which is increasingly implicated in age-related hearing loss. The cochlea's hair cells, responsible for detecting sound vibrations, are vulnerable to damage from reactive oxygen species, ROS. Folate, by supporting glutathione synthesis, an essential cellular antioxidant, may indirectly protect these fragile sensory cells from oxidative damage. This antioxidant role is typically overshadowed by folate's more glamorous DNA-related functions, yet it may be highly relevant in preserving sensory function over decades. It's also worth considering the lifestyle and dietary context in which folate exerts its benefits. Diets rich in natural folate, from leafy greens, legumes, citrus fruits, and avocados, often correlate with better overall cardiovascular and neurological health. These diets tend to reduce systemic inflammation, support microcirculation, and enhance nutrient synergy. In this context, folate may not be acting alone, but rather as part of a constellation of protective factors that buffer against sensory decline. Additionally, folate-rich diets are often inversely associated with conditions like hypertension, diabetes, and obesity, all of which are risk factors for accelerated hearing loss. The implications of this connection are promising. If something as accessible as dietary folate or appropriately tailored supplementation can offer even modest protection against hearing loss, it represents a low-cost, low-risk strategy for improving quality of life in aging populations. Hearing loss is not just a sensory issue. It is strongly associated with social isolation, depression, and cognitive decline. Preventing or slowing this decline through nutritional strategies like optimizing folate status could have far-reaching benefits for public health, especially as global populations age. While more clinical trials are needed to define optimal dosing, timing, and synergistic nutrients, such as B12 and omega-3 fatty acids, the protective potential of folate in auditory health adds yet another layer of significance to this already multifunctional vitamin. In a world where hearing aids and cochlear implants dominate the conversation around age-related hearing loss, folate offers a gentler, more preventive narrative, one that begins not in the audiologist's office, but on the plate.